Over the past 100 years, the global average temperature has risen about 1.3 degrees Celsius, reducing the environmental pollution and greenhouse gas emissions caused by fossil fuels is a mission we have to face. For sustainable development in Taiwan, the Executive Yuan has set a target of 27 gigawatts of renewable energy power generation in 2025, accounting for 20% of the total power generation. In response to the advent of the green economy era, the Executive Yuan officially announced the promotion of the construction of the Sharon Green Energy Science City in Tainan, with the four main targets of energy creation, energy storage, energy conservation, and system integration, to promote the development of the green energy industry and enhance industrial competitiveness. Due to the intermittent instability of renewable energy power generation, the development of a set of stable and reliable energy storage technologies is of importance for the development of Taiwan. Common energy storage methods include flywheels, batteries, compressed air, pumped storage, hydroelectricity, and power-to-fuel. Among them, power-to-fuel is the most suitable energy storage technology for large-scale and long-term discharge. Power-to-fuel is the use of electricity from renewable energy to produce hydrogen through water electrolysis. Hydrogen is stored, and then the fuel cell is used to generate electricity. Examples of fuel cell applications include motorcycles, vehicles, trains, forklifts, drones, submarines, household and industrial generators. For example, Japan's Toshiba released power-to-fuel products in 2015. In addition, the emissions of internal combustion engines of motorcycles and vehicles account for about 25% of the world's pollution. The development of electric vehicle technology is a very important issue. Thereby, the Environmental Protection Administration will only open electric motorcycles and vehicles in 2035. At present, commercial fuel cell vehicles have been sold abroad. Take Toyota Mirai as an example. Mirai, equipped with 110 kilowatts fuel cell and filled with 5 kilograms of hydrogen, can run 500 kilometers. In view of the importance of hydrogen energy and fuel cells, Yuanzhi established the Fuel Cell Center as early as year 2000.
电子中心过去已经20年，开始的时候有一些能源部、能源局的一些计划的支持，还有经济部一些科专，就学术界可以申请科专的计划。那之后，原治大学被选为全国顶尖大学，是因为有燃料电池这样领域的研究的一些突出的表现。
The center has published a total of 592 CSI papers and passed 89 patents. The academic performances are highly excellent. The fuel cell is a power generating device composed of two electrodes and an electrolyte. The electrode uses platinum catalyst. The electrolyte is a polymer membrane of perfluorosulfonic acid, and its function is to conduct protons. When the anode undergoes H2 oxidation to generate electrons, and the cathode undergoes O2 reduction, the theoretical cell voltage at room temperature is 1.23 volts. If H2 and O2 can be continuously supplied to the electrode, the fuel cell will continue to generate electricity, accompanied by water and waste heat. The design of the fuel cell needs to consider several factors. For example, in order to improve the uniformity of fuel power generation, it is necessary to design and install a gas flow channel plate, a gas diffusion layer, and an airtight gasket on the outside of the electrode. Since fuel cells generate water and waste heat, water and heat management and transport of fuel fluid delivery are also key design technologies. The knowledge of professional courses such as manufacturing, heat transfer, fluid mechanics, and fuel cell taught by the Department of Mechanics can educate students on how to optimize the design of fuel cells. In order to improve R&D efficiency, the center designed an 8-channel fuel cell measurement instrument. Fuel cells can be connected in series according to the amount of electricity generated to form a stack to meet the needs of high-power applications such as energy storage and electric vehicles. The center has a rare 6 kilowatts fuel cell analysis instrument in Taiwan. In addition, the X-ray photoelectron spectroscopy can quickly and accurately analyze the composition and valence state of the surface of the catalyst for hydrogen storage materials and catalyst for fuel cells. The transmission electron microscope can identify the crystal structure, particle size distribution and composition of catalyst or hydrogen storage materials. TEM is a powerful tool for improvement of hydrogen energy technology. Currently on the market, hydrogen is mainly produced by the steam reforming method, including 5 reaction units. In view of the future renewable energy, the proportion of water electrolysis hydrogen production methods in the market will be higher and higher. In terms of operating principle, the water electrolysis method is the reverse reaction of the fuel cell. Professor Zhang Guobing developed the membrane electrode assembly to form a water electrolyzer and customized it into a water electrolysis system. He has obtained several patents. Traditionally, hydrogen gas is stored at 130 atmospheres at high pressure. In recent years, hydrogen storage alloys such as the nathan nickel have significantly increased hydrogen storage density and reduced hydrogen storage pressure. The principle of the hydrogen storage alloy is, first, the hydrogen molecule is adsorbed on the surface of the material. Under the action of the catalyst on the surface, the hydrogen molecule dissociates into hydrogen atoms, and then the hydrogen atoms diffuse into interstitial sites of the crystal. The hydrogen atoms in the interstitial sites react with metal atoms to form metallic hydrides. During hydrogen absorption, metallic hydrides also cause lattice expansion of crystal. The steps of the hydrogen storage tank include 1. Take the nathan nickel ingot. 2. Make the ingot into the powder. 3. Pour the powder into the hydrogen storage tank. 4. Place the filter and lock it. In recent years, the Fuel Cell Center has developed new technologies to significantly reduce the hydrogen release temperature of magnesium hydrogen storage materials from the traditional 350 degrees Celsius to 250 degrees Celsius. Our center participated in the energy storage of Green Energy Science City with the research team of low-temperature magnesium hydrogen storage materials and energy storage applications. In 2018, the team teachers organized the 2018 30th Symposium on Hydrogen Energy and Fuel Cells and invited experts from the United States Bloom Energy and Professor Uchida from Yamanashi University to introduce the latest fuel cell-related technologies, attracting a total about 200 people to participate in this event. The 2010 3rd National College Cup Fuel Cell Energy Saving Car Competition was also held by our center. There were 9 domestic hydrogen car competitions in this event. Teachers and students of the Department of Mechanical Engineering of Yuanzhi designed a hydrogen car. Holding the 2018 10th National Student Cup Hydrogen Car Competition, it once again drove domestic attention to the energy issues of hydrogen energy and fuel cells. University of Wisconsin-Milwaukee Director Chu visited our center and gave a lecture on the high-temperature proton exchange fuel cell, and the former president of the Yuanzhi, Professor Zhang, returned to visit University of Wisconsin-Milwaukee. Our center implemented the Fuel Cell and Hydrogen Energy Key Technology Industry Academy Alliance project of the Ministry of Science and Technology and counseled dozens of fuel cell manufacturers and students for internship cooperation. Our center developed a hybrid fuel cell park car with manufacturers and a fuel cell forklift. The Department of Mechanical Engineering of Yuanzhi actively participates in the Ministry of Education's Energy Teaching Plan, strives for teaching funds to expand teaching equipment, and organizes energy activities inside and outside the school to cultivate countless college students and more than 250 masters and doctoral professionals. Yuanzhi provides a series of energy courses, including general courses, introductions, compulsory courses in mechanical department, 4 major courses in energy, creative practice and internship, etc., to cultivate excellent energy talents for the society. A 3-day industrial course on key technology and machine training of hydrogen energy and fuel cells is held before the school starts in September each year. Research and development personnel or students in related industry can apply for the course. A study certificate will be issued after the course. In recent years, the Department of Mechanical Engineering held 3 times of energy storage technology creative poster contest in recent years. Taking 2019 as an example, it attracted 52 teams from 22 universities and colleges to apply. An energy education exhibition is held, in which energy service groups are organized by college students or high school students to introduce energy technology and applications to teachers and students on and off campus with the theme of fuel cell or energy technologies. For the high school camp, the students from the mechanical department introduced the fuel cell principles to the high school students. By holding model car assembly and fun competitions, the university students not only internalized their knowledge of fuel cell technology, but also increased high school students' interest in learning about new energy. Professor Li Qiyuan's team and Professor Zhong Guobing's team won awards. Professors Chang Hui-Wu and Jia Jiesheng's team won the Clean Energy Technology Creative Competition Award for their ability to stimulate the self-driving function of fuel cell vehicles with lithium battery and fuel cell hybrid self-propelled vehicles.